This question is about halogens. Part A. A student adds a solution of bromine in an organic solvent to 2 test tubes. The student adds aqueous sodium chloride to one test tube and aqueous sodium iodide to the other test tube. The student shakes the mixtures, allows them to settle, and records the colour of the organic layer in each mixture. Explain how the student's results provide evidence for the trend in reactivity of the halogens, down group 17 or 7. And write an ionic equation for any reaction that takes place. Use your chemical knowledge to explain the trend in reactivity.
So reactivity decreases down the group, which means that bromine is less reactive than chlorine. So the orange organic layer is going to contain bromine that doesn't react. And then the violet organic layer, because iodine is less reactive than bromine, so that's going to displace, and the violet is going to contain iodine. So that's the first point we need to write for this question.
So now let's write the ionic equation. So the ionic equation is going to be with the violet one because the orange one, there's no reaction, so we can't really do an equation because it will just be the same on both sides. So if we look at sodium iodide, so we've got iodine ions, so iodide ions, and we're reacting with bromine. So because bromine is more reactive than iodine, we're going to produce these bromide ions and then iodine. So we need to balance the equation by putting a 2 here and then 2 in front of the bromide ions. So this is our ionic equation. Now we need to move on to the reasoning using chemical knowledge.
So with this chemical reasoning or chemical knowledge, we're going to talk about the trend going down the group or down group 7. So the first bullet point we're going to write is that the reactivity is going to decrease. The second bullet point is that the oxidizing power is going to decrease, which we can see in this ionic equation because iodine, which is lower in group 7, is not oxidizing bromine, it's reducing it, so its oxidizing power is decreasing. Also, there's a greater atomic radius as you go down the group, and that's going to mean that there's going to be less nuclear attraction as you go down the group because of this bigger atomic radius.
To get the 5 marks for this question, you get a mark for saying that the orange organic layer contains bromine and then there's no reaction, and violet contains iodine. You get your second mark for your ionic equation. You get your third mark for saying that down the group the reactivity decreases, and then one of 4 statements. So the oxidizing power decreases, you gain electrons less easily, you form a negative ion less easily, less energy is released when electrons are gained. Then you get your 4th mark for saying that there is a greater atomic radius, or more shells or more shielding, one of those 3. And then you get your 5th mark for saying that there's less nuclear attraction down the group. Part B. Chlorine is used in water treatment. State 1 benefit and 1 risk of using chlorine in water treatment. So let's start with a benefit of chlorine. So the benefit is that it's going to kill bacteria, but the risk is it's toxic or poisonous. So this is 1 risk. There are 2 more risks you could write for this question. So the other risks are that you form chlorinated hydrocarbons or you form carcinogens or toxic compounds. To get the mark for this question, you must have a correct risk and benefit. So the only correct benefit that they'll accept in this question is that it kills bacteria. Part C. Compound A contains bromine and fluorine only and has a boiling point of 41 degrees Celsius. 1.26 grams of compound A is heated to 80 degrees Celsius. The volume of gas produced is 0.209 decimeters cubed. Under the conditions used, 1 mole of gas molecules has a volume of 29.0 decimeters cubed. Determine the molecular formula of compound A. So firstly, with this question, we need to highlight the key pieces of information. So that's that we have bromine and fluorine only, we have 1.26 grams of compound A, we have a volume of gas produced at 0.209 decimeters cubed, and that 1 mole of gas is equal to 29 decimeters cubed. We want to work out the molecular formula. So firstly, we're going to do 0.209 divided by 29. So that's similar to when you have that 1 mole of gas equals 24 decimeters cubed. You divide your volume of gas by 24 and then you get moles. So if we do this but with 29, we get 0.00721 moles of A. So then we're going to use an equation triangle. So the equation triangle that we're going to use is mass is equal to moles times the relative formula mass. So if we work out the relative formula mass, that's going to be 1.26, which is our mass of A, divided by 0.00721 moles, which equals 174.8, which is the relative formula mass of A. Now we're told we have bromine and fluorine only. Bromine has the relative atomic mass of 79.9 and fluorine has a relative atomic mass of 19. So if we start by subtracting the bigger relative atomic mass, which is 79.9, if we minus 79.9, we get 94.9. If we minused 79.9 again, we would get 15. And 15 is too small, it's lower than 19, so it can't be that because we're told it has bromine and fluorine. So we know it's got 1 bromine because you can only minus 1 bromine. And then if we divide by 19, we get 5. So that means we've got 5 fluorines. So it's going to be BrF5 as its molecular formula. To get the 3 marks for this question, you get a mark for working out the moles of A, a mark for working out the relative formula mass of A, and a mark for working out the molecular formula of BrF5.